Hello friends, this video on P block elements part 23 is brought to you by examfear.com. No more fear from exam. Let's take some questions now. The first question says, how to explain the higher stability of boron chloride over TlCl3? So if you see this thallium and boron, they belongs to same group, right? And you see the going down this has +3 oxidation state maximum. This guy has +1. Why? Because of the effect which we have learned, right? The effect is called inert pair effect. Okay, because of inert pair effect, if you go down, this thallium is more happy to exist in +1 oxidation state than +3. So thallium +1 is more stable. Thallium +3 is unstable. Boron +3 is more stable and boron +1 is unstable, right? This is because of inert pair effect. So if you see in this case, it has +3 oxidation state, it is stable. This is +3 oxidation state, it is not stable, right? So the question is, why boron trifluoride behaves as a Lewis acid? So I have, let's suppose, 3 chlorine here. So if you see, the boron has 6 electrons, 1, 2, 3, 4, 5, 6. To be happy, it needs 8 electrons to complete the octet. So it is a need of 2 electrons. So it is electron hungry. Electron hungry. Since it is electron hungry, it is not happy, it is electron hungry. So it accepts electron pair. Since it accepts electron pair, it is a Lewis acid. Correct? If you react this guy with ammonia, which has lone pair of electron, it attached to this and forms a compound. So the question is, BCl3 and CCl4, how they will react with water. If you see, right, BCl3 structure, if you see again, same similar question, I'm doing it. This is boron trichloride. It is electron deficient. It has 6 electrons, 1, 2, 3, 4, 5, 6. It needs 2 electrons. Water, if you see, it has lone pair of electron, so it will react. It will react and it will form H3BO3 plus HCl. You can write the balance equation. Maybe it is 3 and this is 3. Correct? So since it is electron deficient, it will react with water. It will undergo hydrolysis. All this chlorine will be replaced by OH. But if you see CCl4, right, carbon is happy because it has 1, 2, 3, 4, 5, 6, 7, 8 electrons, right? This guy is happy. Since this guy is happy, it won't react with water. It won't go hydrolyze with water. The question is boric acid a protic acid? Protic acid is something which can give the protons. But boric acid is not a protic acid. Fine. So if you see the react boric acid, this is something we have boric acid. Here also is electron deficient, right? The moment you react with water, and this is my water molecule which has 2 electrons, extra electrons, it merge here because, sorry, there was no electron pair here. It is electron deficient. Boric acid is something like this only. So it has 6 electrons. There is no electron here. It is electron deficient. It reacts with water which has a lone pair of electron, right? And thus, it will form a hydrated species actually. It will form BOH4 minus and H plus. This is one species actually. So it won't give a proton. It is not giving a proton, right? Since it is not giving a proton, it is not a protic acid. It is a Lewis acid. What happens when boric acid is heated? So if you see, when boric acid is heated, we have H3BO3. When you heat this at 370 Kelvin, it loses water and it becomes HbO2. That is metaboric acid. Right? You have seen this reaction. And when you heat this further, this gives water actually. When you again heat this guy, metaboric acid, again heat, increase the temperature 410 Kelvin now, heat of 370, heat further, this becomes H2 B4O7, that is tetraboric acid, and again you heat this, this becomes B2O3, that is boron trioxide. This is red heat, right? So boric acid, we started with boric acid, we got metaboric acid, right? The water molecule is lost. Then again we heated this metaboric acid. You can write a balanced reaction here. You can heat this metaboric acid. We got this, that is tetraboric acid. And again this tetraboric acid, we again reheat this. We got boron trioxide. Boron trioxide. We have to describe the shape for BF3BH4 minus, this is minus actually, and we have to give the hybridization for these species. So BF3, you see I have one boron, I have 3 electrons here, and I have 3 fluorine to add, right? So if you see, this is the shape of BF3. It is sp2 hybridized, correct? Because this is the empty p orbital here, and it is electron deficient. When we talk about BF4 minus, it will be planar actually. Since this is sp2, it will be planar. We talk about BF4 minus, that means you have one more extra fluorine, so it will be something like this. It will be tetrahedral. It will be negative charge. So it will be sp3 hybridized, and it will be tetrahedral. Correct? Because it is sp3, it will be tetrahedral. This is sp2. This has to be clear. What reaction? To just write a reaction to justify that aluminium is amphoteric in nature. So to prove that aluminium is amphoteric in nature, you have to react aluminium with acid, and if you can react aluminium with base, both, and in both cases if reaction happens, I can say that aluminium is amphoteric. So let's start with aluminium with sulfuric acid, dilute, it gives Al2, SO4, 3 and hydrogen gas. Let's balance this. The balance. Let's react aluminium with the base. Let's take sodium hydroxide as the base, a very common base, right? And let's add some water to make it aqueous. It gives NaAlOH. So it's an ionic compound and 3 hydrogens. This is called sodium tetrahydroxoaluminate, right? Sodium tetrahydroxoaluminate. So if you see, aluminium reacts with acid, aluminium reacts with base. If you want, you can balance this reaction also. The next question is, what are electron deficient compounds? Are BCl3, SiCl4 electron deficient? So electron deficient compound which is not forming the octet. For example, BCl3, you see boron dichloride. It has how many electrons? 6, 2, 4, 6. So it is electron deficient. Let's talk about SiCl4. Si has Cl here, Cl here, Cl here, Cl here. So it has 2, 4, 6, 8 electrons. So 8 electrons, that means it is not electron deficient. You have to rationalize these given statements. All for lead. Lead chloride react with chlorine to give PbCl4, and lead 4 chloride react is highly unstable, and lead is not known to form PbA2. So for lead, I know that I have +4 and +2 oxidation state, and this is +2 is stable and +2 is unstable, right? Inert pair effect. The first reaction said lead 2, that is Pb +2, reacts with chlorine to give Pb +4. Is that possible? No. Why? Because Pb +4 is unstable. So this reaction is not possible. The second reaction says that Pb +4 is highly unstable. Yes, because Pb +4 is unstable because of inert pair effect, and it will always form Pb +2. It will always form Pb +2. Okay. Lead is not known to form iodide. PbI4, if you talk about it, has to have oxidation rate +4. So +4 is very unstable. stable. Correct? So this will not be formed. Also, the PBI bond, right, it needs a lot of energy to form this. And since the output is very unstable, so it doesn't form that. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.